So today we're going to be looking at our travel graphs, and travel graphs, luckily, it's not a lot that you need to be able to understand to do them, but it is definitely some interpretation needed. All right, so let us have a look at our travel graphs. I'm going to share my PowerPoint with you. All right, so we are looking at travel graphs. Great. So with travel graphs, there are a couple things that we need to remember. And I'm going to write this in red. So we are going to be looking at distance. We're going to be looking at speed, and we are going to be looking at time. I must put up the chat as well. So remember, if you have questions during, just put them up in the chat. All right. So with distance, what is distance? Distance is how far we have traveled. Our speed is essentially how quickly, let's put it like that, how quickly we are going. And the time is how long it's taking. Now, you might have to work between them. So you very possibly might be given a speed and a time, and you have to calculate a distance. Or you might be given a distance, a time, and calculate a speed. So we need to know how each of these relate to each other. So we have distance, and distance is in meters or kilometers or something like that. Let's say, for example, this is in kilometers. We have time, and time could be in minutes, seconds, hours, whatever it is. So I'm going to put this one in hours. When we come to speed, speed is going to be kilometers per hour. It could be meters per second as well. That's up to you depending on the unit. However, since this is kilometers and this is hours, our speed is how many kilometers are we going to travel per hour. All right. Now, sometimes it's difficult to remember if I need to calculate one of them, what do I do? Do I divide? Do I multiply? What's going on? Well, there is this little thing, and it's got quite a mean name, but it's actually incredibly useful. And it's called the idiot's triangle. Now, no, I'm not calling any of you an idiot. And the reason for that is because I still use this triangle. So if you're an idiot, I'm an idiot. So these units over here can actually help us a hell of a lot when determining what to use. So we can have that our speed over here, distance over there, and time over there. Great. So what we need to do is, if we are looking to calculate one of them, so for example, I am looking to calculate speed. If I'm looking to calculate speed, what I do is I get rid of speed. And then I see that I have distance over time. And that's my formula. Speed is distance over time. And that's how the triangle works. It's quite nice, actually. So what about if I want another one? If I want time, for example, I cross out time, and then I've got distance over speed. And equivalently, if I want distance, I cross out distance, and then I'm working next to each other, which means this is a times. So it's speed times time. So those are the three options you have. And that should make sense because of the units that we are working in. Because distance is kilometers, time is hours, and speed is kilometers per hour. So if I want to calculate speed, I'm taking distance divided by time. In other words, the amount of kilometers over the amount of hours, being kilometers over hours. So the units actually give away what your calculation is going to be. To calculate kilometers, I take kilometers over hours, and I then times by hours. The hours cancel, and I'm left with kilometers. If I want to find hours, I take kilometers over kilometers per hour. And tip and times, because this is kilometers divided by kilometers per hour. I tip and times this fraction, so that's kilometers times hours over kilometers. Kilometers cancel, and I'm left with my hours. So that is a whole bunch of ways to help you find out if you're meant to be multiplying, if you're meant to be dividing. So let's take an example. Here I have a travel graph that has been given to me. And this is in the textbook. It's page 98 in the textbook. And which textbook, you may ask? It is the Blue Book 1 textbook, not workbook. And you are asked a couple questions about this graph. It is about a family car journey. It says, what time did the family set out? Well, what time did the family set out? Well, that's the very beginning. And the very beginning is right over there. So they set out at 7 a.m. Great. All right. Then, question 2. How far did they travel in the first hour? Well, the first hour, you then look at your time axis, because you've been given a distance axis as well. So in time, the very first hour is that bit over there. How far did they travel? Well, at 8 o'clock, they've traveled a distance of 50 kilometers. Therefore, they've traveled 50 kilometers in their first hour. Reminder, this is page 98 in book 1. What was their average speed? So we are asked to calculate speed. And we can use our triangle to remember that speed is distance over time. So my distance was 50 kilometers. My time was 1 hour. So therefore my speed is 50 kilometers per hour. So that means that if they travel at the same speed, every hour they will travel another 50 kilometers. So question says, what if it was per minute? Well, if it was per minute, you generally then use meters, and you would then have 50,000 meters divided by 6, it would be meters per second. So it's 50,000 meters divided by 3,600 seconds. Why 3,600? Because it is 60 minutes, and then 60 minutes is 60 by 60 seconds. So that's 3,600. Now, it doesn't matter if you then do meters per second or kilometers per hour. However, they have given you kilometers and they have given you in hours. So most likely they are looking for kilometers per hour. Both will be marked correct, but meters per second means you're going to be dealing with bigger numbers that might not be very nice to work with, and also you're going to be wasting time in converting stuff when you don't need to. All right. Question 3. What time did they stop for breakfast? Well, how do you know when they've stopped? Well, they would have stopped when their distance stops changing. And their distance stops changing between there and there. I know it's not changing because it is still at 50 and it stays at 50 for a whole hour. So what time do they stop for breakfast? Between 8 a.m. and 9 a.m. All right. How long did they stop for breakfast? Well, how long is it flat? Between 8 and 9 a.m., it's 1 hour. How far did they travel between 9 a.m. and 11 a.m.? So from here to here. And the question is, how far? Far meaning a distance. So from 9 to 11, 9, they're at a distance of 50. At 11, they're at a distance of 100. So therefore, 100 minus 50 means this distance is 50 kilometers. The average speed is calculated by dividing the total distance traveled by the total time taken. We know that through our triangle. Calculate the average speed during these 2 hours. Well, average speed being distance over time, the distance they traveled was 50 kilometers. However, what's different is that it's now no longer 1 hour, it is now 2 hours, which means that that is going to change. It is now over 2 hours because it's from 9 to 11, and therefore this becomes 25 kilometers per hour. 50 divided by 2 is 25. All right. The family reached a motorway at 11 a.m. So now we're looking over here. What was their average speed for the next hour? Well, the next hour is 11 to 12. What's their average speed? Well, the time is not 2 hours. It is now 1 hour again. And how far did they travel? Well, they were at 100 k's distance. Over here, they're now at 200 k's of distance, meaning that they have traveled 100 kilometers. Which means if we take the 100 kilometers and we divide it by the 1 hour, we get 100 kilometers per hour. That is their average speed. And you'll see that also your gradients become steeper or flatter according to your average speed because you're taking a distance, which is a y, and dividing it by time, which is an x, which is your rise over run, which is a formula for gradient that you dealt with when you dealt with straight lines. So we can see that this gradient is steeper than that one, but this one is the steepest because it's got the highest value. It says, how long did the whole journey take? Well, it took from 7 to 12, and we can subtract those 2 times, and we get 5 hours in total. How far did they travel in total? Well, they started at 0 and they ended at 200. So they traveled 200 kilometers in total. What was their average speed for the whole journey? Well, you would then divide these because speed is distance over time, and you get 5 into 200 is 40 kilometers per hour. So remember, this one over here was 50 kilometers per hour. This one was 25. And this one was 100. So one's averaging these, taking into account how many hours they were for, and then this one over here was also a 0. We end up with an actual average of 40 k's an hour. So that's quite interesting. Then you're told something slightly different. Then you're told that a second family starts out on the same journey, but this time by train, not by a car. They leave at 9 a.m., which is over here, and arrive at the same place at noon, being 12 p.m. over there. Show this journey on a graph. Well, if they travel by train, they're going to go straight through. So this is going to be one straight line all the way through. And then it says, what's the average speed of the train? Well, they've traveled 200 kilometers. And how long did it take them to travel the 200 kilometers? From 9 a.m. to 12 p.m. is 3 hours. So 200 divided by 3 hours gives me 67.7 kilometers per hour, or 67 2/3.